Greetings, this is m squared. We're going to multiply and divide some rational expressions, and these are kind of a step up. You notice that when you look at them, there aren't any monomials anywhere. They're all binomials and trinomials. So remember, whenever we multiply or divide fractions that have x's in them, variables in them, we want to factor first because you can only cancel factors. And that's really important to remember. So the first one here, we notice this is a binomial with a minus sign. This is a binomial with a minus sign. We know that it's a difference of two perfect squares. We use our pattern for that. So we know that up top we're going to get x plus 2x minus 2. Remember, that's our pattern for the difference of squares. You could always check it using FOIL if you don't remember or aren't familiar with that. And down here, the difference of two perfect squares. So we're going to get 2x plus 1 and 2x minus 1. And then we are multiplying it by this fraction. And this fraction doesn't have any squareds. There's no common factors. Remember, your first step in factoring is to look for a greatest common factor. There weren't any here, there weren't any here. But you really need to remember that because it does help you if you can get rid of a greatest common factor first. And so now that everything is factored, we are able to cancel like factors. So 2x minus 1 cancels with a 2x minus 1. And x plus 2 cancels with an x plus 2. So our answer ends up being x minus 2 over 2x plus 1. These aren't alike. X minus 2 is not here. It does not go into that. Just because you see an x or a 2, don't get cancel happy and start canceling things. You can only cancel a factor of 2 with a factor of 2. This is not a factor of 2. It's a minus 2. Keep that in mind. Okay, the next one. We have to factor first, and then we notice it's division, so we're going to have to flip that. That's what division means. Flip that baby. So the first one, it's a binomial. It's a difference. That's a perfect square. That's a perfect square. So I know I'm going to have an x plus 1 and an x minus 1. This is a trinomial. Well, it's a pretty simple trinomial because that's a 2 and that's a 1. There's only two things that multiply together to get a 1. And there's only two things that are going to multiply together to get my 2x squared. So I know that's right. So now I have to figure out the signs. I know I need a negative 1. Well, if this way I get a 2x, this way I get a 1x. And if I need a negative 1, I have to have a 1 minus 2. So this is a 1x minus 2x gets me my negative x if I'm checking with FOIL. And when I factor this, since I'm going to change it to multiplication, I'm going to factor this one and put it up here, factor this one and put it down here. Now this one's the easiest one because it's an x squared minus 4, which is a difference of two perfect squares. We just did that a minute ago. You might remember it. And then this one. Well, I always look over here. I know that's going to be in the top, so I look at all these and say, what will be a common factor? Because most of the time, one of those is a hint. And since I have a 2x plus 1, I'm pretty sure that that's what I'm going to have over here. So I'd actually put that down and see. If it's not right, we'll change it. So let's say it was a 2x plus 1 so that we could cancel with that. What would this have to be? Well, the only way to get a 2x squared, if I have a 2x, I need to multiply that by an x. And if I have a 1 and I need to get a negative 2 by multiplying, that one's going to have to be a negative 2. So then I check it. This would be a negative 4x. This would be a positive 1x when I do my outers and my inners. And 1 minus 4 does indeed get me that negative 3. So I've checked that, so I know that's correct. And now I start canceling like factors. X minus 2 cancels with x minus 2. 2x plus 1 cancels with 2x plus 1. X minus 1 cancels with x minus 1. And we are left with an x plus 1 in the numerator and an x plus 2 in the denominator. Well, you'll notice in this one that it's division, so we're going to have to flip this fraction. Always flip the fraction to the right of the division sign. But you'll notice these cubes. That means you're going to have to use your sum and difference of cubes formula. Hopefully you remember what that is. If not, look it up. I'm going to show you how to do it, but you got to be careful with these cubes. If you don't know the pattern, it's pretty impossible to figure it out. So, no greatest common factors again. I've looked at that. This is a difference of perfect squares. The tricky part about that is, well, let me do it up here. When I say x squared plus y squared, and then I say x squared minus y squared, when I factor this, using my difference of two squares, you'll notice that this again is a difference of two squares. So we're going to have to factor that again, and sometimes that happens. So I get the x squared plus y squared, which is a sum of perfect squares, which is never factorable. It's always prime. This one I can factor again, so I'm going to do that right now. That'd be an x plus y and an x minus y. Then I'm going to factor my sum of cubes. When I factor a sum of cubes, I have two parentheses. One's going to have binomial, one's going to have a trinomial, and the first parentheses always uses the same sign as that one, so it's going to be an x plus y, so it's the cubed root of whatever's there. And then in the first and the last here, it's always whatever these guys were squared, and then here it's whatever they are multiplied with the opposite sign. And this last sign is always plus. So let's see if I can kind of get that over here. We're going to flip this fraction, so we're going to x plus y on the top. And then it's a difference of cubes now. So again, the cubed root of x cubed and the cubed root of y cubed with the same sign. Then I square them both, put them on the ends of the trinomial. I multiply them together and put them in the middle with the opposite sign there, and this is always plus. And now I'm going to see what I can cancel. An x plus y cancels with an x plus y. And is that it? I believe that's it. And so our final answer would be x squared plus y times x plus y. Oops, sorry, that's a y squared. Over x squared minus xy plus y squared times x. Did I forget to cancel these x minus y's? And then I wrote that one down wrong. Sorry about that. The x minus y's cancel too. So, oh, and then I just, well, I was writing the right thing anyway. Anyway, so you got that, and then on the bottom you have this. And I would not recommend actually multiplying those trinomials out. This gets kind of messy. I'm sure your teacher would probably let this stand as the answer. There's no way to continue factoring that because we knew there wasn't a greatest common factor. So factoring that, those are both prime. So that's how you multiply and divide these rational expressions. This is M squared, signing out.